11:58 a.m. local time. The aircraft experienced a tremendous jolt and a loud bang while flying at a height of 36,000 feet over the Pacific Ocean. The plane trembled fiercely, and panic took hold of the passengers. The pilots experienced considerable shaking, making it difficult for them to read any instruments, and both the autopilot and the autothrottle disconnected. The aircraft became unmanageable and rolled to the right at a 40-degree angle. Could the pilots make it to their target without incident, or were they destined for a terrible end below in the ocean? This is the account of Flight 1175 on United Airlines. A day before Valentine's Day on February 13, 2018, 363 passengers and 15 crew members took United Airlines Flight 1175 from San Francisco International Airport to Honolulu, Hawaii. In ideal circumstances, a direct flight that largely spans the Pacific Ocean from San Francisco to Hawaii typically takes 5.5 hours. During this direct path, no other countries are overflown. It's likely that the majority of passengers were traveling to the Hawaiian Islands in honor of Valentine's Day. They had no idea at that precise time that a surprising and exciting turn of events was going to take place, something they would never forget. A Boeing 777-200 was the plane assigned to this flight. This is a wide-body, twin-engine, long-range aircraft that can carry up to 545,000 pounds upon takeoff. The Boeing 777 had a comparatively low accident mortality rate at the time of the occurrence. Since it was new, the aircraft has amassed nearly 90,000 hours and over 16,000. An aircraft engine's whole run from startup to shutdown is called a cycle. This involves starting the engine, using it for the duration of the trip, and then shutting it off. Regardless of the length or distance of the flight, each cycle reflects the engine's complete employment. This is a crucial aviation safety measure that tracks the deterioration of safety procedures. The turbofans on the aircraft were Pratt & Whitney PW 4077 models. This turbofan engine has 2 spools and operates on axial flow with high bypass. 3 pilots made up the crew in the cockpit. First Officer Paul Ayers, 60, was the pilot in flight, and Captain Benham, 57, was the pilot monitoring. Furthermore, Ed Gagarin, a United Airlines first officer who was not on duty, was occupying the jump seat. Out of his over 13,000 flight hours, 360 were spent aboard the Boeing 777. Throughout his 40-year aviation career, he had also participated in acrobatic flight. Later on in the flight, this experience would come in very handy. With over 11,000 flight hours under his belt, First Officer Ayers had flown over 11,000 hours on the Boeing 777 in particular. It was time for pushback. By communicating with the cockpit, the ground controller stationed close to the aircraft verified that everything was in order. A robust machine called the pushback tug caught hold of the 777's nose gear. It started to push the airplane away from the gate with ease and efficiency. Even though the operation was routine and had been done countless times, the ground crew and pilots' accuracy and cooperation were always a technical ballet. The tug released its hold and the pilots took control of the aircraft as it aligned with the taxiway. The engines hummed to life, heralding the start of yet another adventure. The flight attendants conducted their safety briefing within the cabin, their words a familiar ritual for seasoned travelers and a crucial introduction for novices. Some of the passengers paid close attention while others were engrossed in their thoughts or electronics. Paul, the co-pilot, consented to fly the first leg to Honolulu when Captain Benham requested him as the 777 approached the runway. Paul turned up the engines for takeoff thrust after getting the all clear from air traffic control, and the plane started to move faster down the runway. Paul would be able to fly the first leg to Honolulu once it achieved the required speed. Raise the nose by pulling back on the control column. The aircraft took off when its back wheels broke free from the runway last. San Francisco International Airport shrank quickly as the jet rose, becoming a tapestry of lights. The landing gear was retracted, and the machine's well-known noises indicated that it was safely stored. The Boeing 777 took off, and the flight went without a hitch. After the aircraft reached its cruising altitude, the two Pratt & Whitney engines hummed smoothly, and the skies stayed clear for the next leg of the flight. The cabin staff took care of the customers' requirements and made sure they were comfortable for hours on end without any significant mishaps. The aircraft was over the Pacific Ocean, flying steadily. Passengers were blissfully ignorant of the catastrophic events that would soon occur, and instead, a peaceful and repetitious sense took over. The pilots made contact with Honolulu Control Frequency for a routine check-in several hours into the flight. They were able to access the most recent weather data from the aircraft's onboard computer system during this conversation. The data showed a visibility range of 10 miles in cloudy skies at a height of 1,000 feet. It was also reported that the temperature was approximately 70 degrees Fahrenheit. After performing a descent checklist, Captain Benham momentarily exited the cockpit to use the lavatory. Not long after his return, the airplane was forcefully and unexpectedly shocked by a tremendous explosion. The autopilot and auto-throttle systems disengaged as a result of this incident. The plane started to tremble violently, making it difficult to read the equipment in the cockpit. The aircraft's severe shaking also produced a deafening noise, like the noises of bending and crushing metal in the fall of a building made of metal. The harsh surroundings compelled the two pilots to yell in order to converse. Far from any landing location and flying over the Pacific Ocean at 36,000 feet, the aircraft suddenly rolled to a 40-degree inclination to the right, becoming unmanageable. The right engine suffered a full-length fan blade fracture, which the pilots were unaware of at the time. No one could figure out what was wrong with the airplane, so the captain declared an emergency. Leaving the passengers inside the cabin frightened for their lives. Attempting to adjust the aircraft's steep angle, Captain Benham requested First Officer Paul's aides to tip the nose downward in order to level the aircraft. They both tightly adjusted the controls to their maximum potential and floored the throttle. Maximum, an essential maneuver to keep the airplane moving at this crucial moment. To halt the rolling, Captain Benham engaged the left aileron and pushed the left rudder. His 40 years of flight experience, which includes acrobatic flying, are now useful. He instinctively looked for a vital point of balance to keep himself from falling into the water. He deftly shifted the nose of the aircraft as everyone was confused about what had gone wrong. He brought the airplane back into alignment with its typical flying path by regulating its roll and height. The jet's condition was unknown to Captain Benham and his co-pilots in the first 30 seconds after the mishap, since the engine instruments were showing normal readings. This made it unclear what was causing the airplane to become unstable. But after these first few seconds, important information was revealed by the crew warning system and the right engine indicator. The engine was not under any pressure. With this knowledge, Captain Benham concluded that the right engine had failed, but he was still baffled as to why the plane was still trembling badly. First Officer Paul was told by Captain Benham to start the catastrophic engine damage checklist right away. They proceeded through each item on the checklist together. Paul finished it and turned off the right engine when he was still 200 miles from Honolulu and over the Pacific Ocean. After the right engine was turned off, the vibration decreased, but the aircraft's uncontrollable behavior persisted. Captain Benham maxed out the throttle on the left engine in order to keep the aircraft under control and control its fall, attempting to descend the aircraft at a leisurely pace of 1,200 feet per minute. The crew made the decision to call for help. While Ed was instructed to collect the vectors directly to Honolulu International Airport, Captain Benham gave Paul instructions to complete the drift down checklist. With just one engine left in service, Captain Benham maneuvered the aircraft with dexterity. The plane encountered the clouds while descending and lowering its speed to 241 knots as it fell to flight level 330. Aerodynamic difficulties were encountered throughout this descent, especially with the right wing's disturbed airflow. It occurred to Captain Benham that trying to boost airspeed by pressing the nose down might jeopardize the chance of making a landing in Honolulu. However, increasing the nose to lower the aircraft's speed increases the risk of a stall. The ideal airspeed, according to Captain Benham, is between 245 and 255 knots, which guarantees steady flight without stalling. He expected a one-shot approach and landing in Honolulu owing to altitude loss, since the left engine was only producing 90,000 pounds of thrust and the right engine had shut down. Through constant calculations of altitude, airspeed, and distance, Captain Benham was able to maintain control in difficult circumstances. Paul was instructed by Captain Benham to activate the autopilot and autothrottle. Regretfully, these controls were not operational. The plane by hand all the way to Honolulu. The cabin crew was informed by Captain Benham about the problems with the right engine, and he also hinted at the prospect of an oceanic ditching because of control problems. He gave them instructions on how to get the passengers ready. In order to identify the issue, the captain ordered Ed to snap a photo of the right engine. The pilot was still perplexed as to why the aircraft was trembling and why maintaining a shallow dive required applying full speed. Ed showed the pilots a short film he had taken of the damaged right engine. The issue made sense when it was discovered that the engine's cowling had been ripped off. When the captain finally realized that the aerodynamics were compromised, they got in touch with the Airlines Network Operations Center for help with the checklist and to let them know about the situation by calling Honolulu's local control center. Tension rose in the cockpit as Captain Benham set the flaps to 1. As soon as the flaps engaged, they felt a wave of relief. The runway lights appeared as the aeroplane moved through the cloud levels. Paul obeyed the captain's request to drop the landing gear with promptitude. Paul then gave the captain a rundown of the go-around procedures, but Captain Benham made it plain that they were only going to get one shot. The pilots felt relief rising once more as Paul lowered and locked the landing gear. When the last bit of cloud lifted, the aircraft's nose lined up with the center line of the runway, showing the tarmac stretch that would be their destination. At an airspeed of 180 knots, they chose flaps 5 and continued until flap 15. The runway widened, details sharpening, firming just enough. Captain Benham decelerated the airplane gradually. The sound of the tires touching notes resonated beautifully in the silence of the cabin, and then they decelerated as they skillfully applied reverse thrust. As soon as the passengers realized the landing had gone well, cheers went up throughout the cabin. Paul pulled to a halt and told the captain he could let go of the controls. It was then that Captain Benham realized he had held the throttle with his right hand for 40 minutes while keeping a tight grip on the yoke with his left. It was decided that it was safe to taxi the aircraft to the gate following a careful examination by firefighters and aircraft rescue professionals. There were no injuries during the 363 passengers, 3 pilots, and 12 flight attendants' usual deplaning at the gate. Following the event, the FAA, the NTSB metallurgists, and the Pratt & Whitney Materials Laboratory all moved quickly to launch a comprehensive inquiry. In order to pinpoint the problem, this thorough analysis included looking through the aircraft's documentation and performing a direct engine examination. In the right engine, investigators discovered a full-length fan blade fracture. Along with multiple dings and gouges, they also discovered a tiny hole close to the right engine in the fuselage. On the right side of the fuselage, near seat rows 20 and 21, just below the window belt, there were 2 little dents and punctures. Fan blade number 11 of the engine was found to have a transverse fracture across the aerofoil, immediately above the fairings between the bases of each blade, upon examination of the fan blades. The other fan blade, designated as fan blade number 10, broke at roughly mid-span across the aerofoil. Upon examination, it was discovered that the hollow core fan blade's inside surface had a fatigue fracture that originated from below. The service records uncovered during the examination showed that the engine's most recent overhaul occurred in 2015. Pratt & Whitney was employing thermal acoustic imaging, a new and still developing technology, at the time to test the endurance of their products. The research pinpointed the precise position of the blade fracture, but Pratt & Whitney experts discounted it as a paint problem. The right engine inlet assembly was mostly missing. Not retrieved were the forward bulkhead, all of the inlet lip skin, the majority of the inner and outer barrels, and roughly half of the rear bulkhead. The fan cowl was missing much of its inner and outer portions as well. At sea, the missing parts were lost. During engine fan blade out certification testing, the inlet cowl structure used an aluminum bulkhead, but on production aircraft, the intake aft bulkhead was made of carbon fiber reinforced plastic. Aluminium can yield while absorbing the same amount of energy as carbon fiber reinforced plastic. The aft bulkhead design made of plastic reinforced with carbon fiber was shown to be less sturdy through structural analyses of the inlet and fan cowl, compared to the aluminum bulkhead that was put through testing for engine certification, which might have led to its separation. The pilots reported that there was intense shaking after the engine intake broke. After the initial hit, the aircraft began to roll to the right due to the considerable loss of stability caused by this damage of the aerodynamic surface. The FAA released an airworthiness rule in 2019 that required routine engine checks based on usage cycles in order to stop such an incident from happening again. More specifically, a requirement that other national aviation authorities have embraced was the introduction of a fan blade check every 6,500 flight cycles. Boeing updated the FAA on its efforts to fortify the 777 engine covers in August 2020. Regulators were informed by the manufacturer that it had made the decision to modify and provide new coverings so that airlines could repair their fleets. Every passenger on the flight received a complete refund from United Airlines in order to start the reconciliation process. The Airline Pilots Association awarded the cockpit crew the Superior Airmanship Award a year later for the aircraft's safe landing. The brave deeds of Captain Benham are particularly noteworthy, as he exhibits remarkable resolve and poise despite tremendous stress. He held onto the throttle and yoked the entire last 40 minutes of the trip, manually bringing the airplane to a safe landing. Thank you all for tuning in. Don't forget to like, subscribe, and hit that notification bell so you never miss out on our future content. Until next time, stay curious, stay creative, and keep exploring.